All right, 10.2 is parabolas. I know we've done parabolas, okay, but this is a different way. The parabolas we've done have been in quadratic form, and they have only been parabolas that open up and down. We do have parabolas that open left and right, okay? So I think this is a little bit easier than the quadratics in standard form, okay, the ax squared plus bx plus c. But these are also going to look at parabolas that open left and right, okay? So when you have, and what's going to happen is we're going to do all of our conic sections with vertices and centers at 0, 0, and then one of the last sections is going to shift all of them off of 0, 0, okay? So we're starting with basic ones first, okay? So parabola, by definition, is going to be all points that are equidistant, so the same distance from a fixed point. And that fixed point is called a focus. With a parabola, you have one, okay? One fixed point. So equidistant from a fixed point called a focus, and a line called a directrix. Okay. So if you think back to parabolas, right, we saw that a parabola has a vertical axis of symmetry, or it just has an axis of symmetry. If the axis of symmetry is vertical, it opens up or down, okay? We can have parabolas that open left or right, and then in that case, you're gonna have a horizontal axis of symmetry, okay? So just for us right now, okay? Just to look at our definition. Here is our parabola, okay? This is the vertex. This applies no matter which way it opens. There's a fixed point inside the parabola, okay, called the focus, and the line is outside the parabola called the directrix. Every point, so if I have a point here, it's going to be equidistant to the focus as it is to the directrix. So these have to be congruent parts, okay? The vertex is halfway between the two, okay, because it has to be equidistant from the focus and the directrix, okay? So every point is equidistant to this fixed point and this directrix, okay? So when you look at your notes and your parabolas, okay, we have 4 options. We can have parabola that opens up, a parabola that opens down, opens right, opens left, okay? In each case, the focus is inside the parabola and the directrix is behind the parabola, okay? So when we look at these, we have 2 standard type forms for these parabolas, okay? And it's a parabola, so you only have one variable squared, okay? So either your equation is going to be x squared or y squared, and then the form is 4p times the other variable, okay? If x is squared, it's going to open either up or down. And if y is squared, it's going to open left or right, okay? P tells us how far it is to the focus and the directrix. So the focus is going to be at 0p or at p0. So if it opens up or down, it's at 0p. If it opens left or right, it's at p0. The directrix is going to be opening up or down, it's y equals the opposite of p. And if it opens left or right, x equals the opposite of p. And then if x is squared, you have a vertical axis of symmetry. And if y is squared, you have a horizontal axis of symmetry. Okay? If p is positive, you're either going to open up or to the right, and if p is negative, you're going to open down or to the left. And that depends on x or y being squared. Okay? So these are parabolas with the vertex at the center or at the origin. We will look at in another section when the vertex is not at the origin. Okay? All right. So working with these forms, okay? We want to identify the focus and the directrix and draw the parabola for x equals 3/4 y squared. Okay? Well, the first thing you have to do, and we always do this, is we put it in standard form. Okay? So for parabolas, the standard form always has the squared term isolated by itself. So we're going to rewrite it. Since y is squared, we want y squared by itself. Okay? So you do that by multiplying by 4/3. So we get y squared equals 4/3 x. Okay? Now it's in standard form. Then, to find the focus and the directrix, you need the value for p. Okay? Because y is squared, that means that the focus is at p0 and the directrix is at y is squared, so the directrix is x equals the opposite of p. So for the focus and the directrix, you need the value of p. P is the distance from the vertex to the focus, or the vertex to the directrix. Okay? So in standard form, y squared equals 4px. Okay, so what this tells us is that 4p is equal to this number. So 4p equals 4/3. How do you get p by itself? Well, you divide by 4. So 4/3 divided by 4 is just 1/3. So that tells us that our focus is at 1/3, 0. So this is a parabola that's going to open to the right. And the directrix is at x equals -1/3. Okay? So we found the focus and the directrix. That's the first thing we were asked to do. Then we're being asked to graph this. Okay? So to graph these in this new form, the first thing I would do is identify which way it opens. Okay? And then you're going to make a table. Okay? So we want to look at this to decide which way it opens. This is positive, and we found out that p was positive 1/3. So it's positive, y is squared. So that means it's going to open left or right because y is squared. But p is positive, so it's going to open to the right. Okay? Then we make a table. So an xy table, right? So pick either x or y, right? In this case, if x is 0, then y squared equals 0, and the square root of 0 is 0. You want to pick x values, if you're picking x, that make it easy, okay? Because if I look up here to get y by itself, it's going to be y is equal to the positive or negative square root of 4/3 x. So in some ways, because 4 is a perfect square, you kind of want to make it so x cancels out the 3 and is a product essentially. Okay, so if x is 3, then we get plus or minus square root of 4, which is positive or negative 2. Multiples of 3. So if I pick 6, then I get 4 times 2, which is 8. And the square root of 8 is plus or minus 2.83. This is okay to get a decimal because you just want to see an approximate for your y values. Okay, and then we'll do one more. So if x is 9, then we get 4 times 3, and the square root of 12 is plus or minus 3.46. Okay, so I'm going to do my graph now. So 1, 2. Okay, when x is 0, y is 0. That's good. That's our vertex. Okay, we know it's opening to the right. So when x is 3, y is 2 or negative 2. When x is 6, almost to 3 and almost to negative 3. And then almost to 4, almost to negative 4. So we get a parabola that is opening to the right. The focus would be here, and the directrix would be behind it at x equals negative 1/3. Okay? So that's how you graph them in this form. And then you want to, we can also take a graph and write the equation. Okay? All right, so here is the graph of our parabola. The vertex is at 0, 0. Focus is at negative 3, or negative, not negative 0, 0, negative 3. And then you have a point at 5, negative 2. And negative 5, negative 2. Because they are mirror images, right? They're symmetric. All right, so to write our equation, okay, we know it's going to be something squared equals 4p times our second variable. So it's opening up and down, right? Technically down, which means that it's going to be an x squared 4py. Okay, so it shows us that the vertex is at 0, 0. Right now that's not super important because they're all going to be at 0, 0. But eventually they're not going to be at 0, 0. Okay, so you need to know that where the vertex is. With a parabola, p is the distance from the vertex to the focus. Okay, so distance from 0, 0 in this case to 0, negative 3. Okay, so when I look, this is only negative 3 units. Okay, this is the key to remember later on. Distance from the vertex to the focus is p. Okay, so that tells us that the directrix is at y equals positive 3 up here. Okay, all right, so you found the length of p, now you plug it in. So x squared equals 4 times negative 3 times y. So x squared equals negative 12y. It's the equation of the parabola that is shown. Okay, so just changing our form a little bit. I think it's a little bit easier because you know where your vertex is, and then you just make a table.